I neglected to ask Dr. Vimy if all of these wires blow up at a certain time and we're playing roulette to see who gets to go. It's an honor to be able to stand before you today and to speak of some things that are near and dear to us. If I might ask for the slide projector, please. So that all of you know, we hail from the place where the plains meet the mountains in Colorado Springs, Colorado. This is a view from our front office door, and that happens to be a beautiful golf course right below the door there, so that any time we get tired of working with the bugs, we head on down. Our facility is about 1,900 square feet. Our laboratory is divided into two sections now. It's a joy to get off the plane and be able to work again. We have a clinical laboratory that provides reactivity testing, and then we also have a research side of the laboratory, and we carry on a substantial spectrum right now of privately funded research. Today we'd like to talk about some of the adverse effects that materials can have on blood and microbial cells. And we'd like to look at some interesting things that we have taken turns at in the lab that may suggest that some of these effects are either protectable or reversible. I'd like to begin with a statement. It's a favorite of mine, and I only recently found it. I think this ought to emblazon on everybody's mind. There's such a thing as pathological skepticism, and it's just as bad and damaging as so-called pathological science. Many times those of us who are in the area of amalgam removal, those of us who are concerned about the toxicity of biomaterials, are accused of pathological science. And we would only invite those colleagues who take that view, and I appreciate Dr. Vimy's comments before me, that the science is where we find the answers. We can set our biases and opinions aside, but we want to avoid pathological skepticism. In our observations, we have noticed that blood cells can have characteristic appearances and shapes, and that those are very often commensurate with structural and cellular content. We've also noticed that blood cells respond to and interact with their environment as needed to accomplish their function and to persevere. In essence, we have learned that blood cells are extremely tough, resilient bodies. We have also found that they can change certain of their functions, appearances, and qualities commensurate with the environment and their own state of well-being. And for this reason, using proper systems and observational techniques, we have found that blood cells may be a useful indicator of not only general health and systemic stasis, but also a very useful marker and observational tool that quickly tells us when certain toxicities or physiologic impairments may be taking place. In our observations, we've also learned that longitudinal blood cell observations may be useful in the detection of reversals. That is to say, if I take a test today and then over a period of days or weeks continue to follow this patient, our experience now is showing that there may be ways in which we can detect turnarounds either for the better or the worse. We also notice that full color and motion studies of live blood cells are frequently superior to fixed static stain studies. We notice that very few laboratories are willing to equip with the necessary materials to do these studies. If I went to any group of hospitals here in the Chicago area, many of them very fine and with fine reputations, I would find very few that are actually equipped to do a complete live cell study with proper equipment. In our observations, we have also found that by the use of spot spectroscopy, in properly illuminated microscopic systems, we can tell something about what's happening in a given cell. We know something about whether high-energy phosphate bond expenditure is taking place at an accelerated rate. We know if peroxidase activity is present based on the fingerprinting of the spectrum that can be taken through the microscope with spot spectroscopy. And finally, these color motion studies of live blood may be useful in monitoring microbial presence and activities. In prior presentations to the Academy, I've tried very gingerly to sidestep the microbiology issue. But with the work of Dr. Summers, as well as those outside of the Academy group, we are beginning to see that the microbiology can no longer be ignored. And I speak here not principally of classical microbiology. Rather, I would like today specifically to turn some of our attention to look at the microbiology of cell wall deficient and cell wall divergent microbial forms, those that can take multiple forms and shapes, that give up their cell walls. And once they've given up that cell wall, many of them leave carbohydrate-based metabolism behind. They move on into nitrogen or sulfur-based metabolism and begin to do strange things intracellularly, as well as in the plasma of a patient. I might add that in the state of Colorado, we now have 2 microscopes capable of imaging such things, and not one of them is hospital or pathology lab-based. And I have a feeling that we're going to find that is true in many cases. It is my belief that this is an emerging technology and that the microbiology will have to be more carefully paid attention to. The infections that we encounter do not always come from the outside in. We are beginning to learn, and I know I've been laughed out of an American Society for Micro Roundtable over this issue, that there is a normal flora of the blood. And that normal flora is present in forms that, number one, will not be classically stainable or recognizable in fixed and stained specimen. Number two, it does not metabolize normally. And number three, you will be exceptionally fortunate if you ever pick one of these up, even in a long-term blood culture. There are special techniques and requirements for culturing in this area. The blood cell observations that we have made then would suggest that the morphology, the spectral qualities, and the conditions constitute normality, etc., based on their appearance. I would also like to mention that in our studies we use Naisson's microscopy. This is a modified dark field technique which requires several key components. We notice that it is capable of providing a stimulatory illumination, and that illumination causes biological material to give off light in characteristic color. Key to Naisson's is color. We can get a lot of beautiful dark field equipment, but if the color is not there, we've lost a substantial part of the value. We also note that these systems can be retrofitted to a number of commercially available high-quality microscope units that you can get from companies such as Olympus, Nikon, Zeiss, and Leitz. We would notice in this particular microscopy system that we do need a properly modified dark field condenser. Key to this system is mercury vapor lighting. There must be an ultra-rich, ultraviolet component. If the ultraviolet is not there, you've wasted $3,000 buying a Naisson's condenser. It is in the ultraviolet that certain polarizations and manipulations of the light take place in the condenser and not in visible spectrum. We suggest that the condenser, which you can see here, is not all that complex from its outside appearance, but we do note that it has a number of optical qualities specifically geared to manipulate UV and carry without major modification visible spectrum. We also notice that the light source not only needs to be mercury vapor. We have a 100-watt system. We have looked at several. And folks, we find that 100 watts is the minimum that I would dare to work with. If I could afford it, we'd go to 250. I might add that that crazy lighting system cost more than the basic microscope did. We need an iris-equipped oil immersion objective, 100x minimum, and we need fluorescence-qualified optics. We do not want spurious suppression or generation of fluorescence because of the cements and other qualities that are used in the glue. In our particular system, although I have a Nikon base, our objective is from Olympus, and it was custom modified by the Nissan's organization. We noticed that 15 or 20x eyepieces delivering 1,500 to 2,500 diameters are desirable. We say 2,500 here, and someone says, where is your math? In the photo tube, we also have some multiplying capabilities. And finally, we need a trinocular head to permit television feed. In the head that we use, it's the simplest that Nikon makes. These will be similar in microscopes that are available to you. The little black piece that you see at the top with the cord coming out the top is the television camera. And this particular unit is capable of delivering about 470 lines horizontal of resolution in color. We need high-resolution color, and we need a monitor capable of doing this. This particular microscopy does require television imaging. The television CCD pickup is capable of spectral amplification that will enhance the color, and again, that's where the key is. If you work in black and white television, you do not get the benefit. Many people who have tried to do these techniques have tried to use common glass slides. When you purchase your slides and cover slips, if you want to try this, please be sure that you get glass that is fluorescence qualified. Many glasses suppress UV. They will suppress some of the spectral qualities, or in other instances, they actually emit spectra of their own when stimulated by ultraviolet. And finally, we suggest that a good Super VHS or high-band 8mm recording system is desirable for record keeping. This is the system that we use in our laboratory, the camera control unit here standing on top of a Super VHS deck. If some of you can afford the $40,000, $50,000, or $60,000 that are necessary, you can get super high-resolution imaging recorders. We've not been able to afford that. Each time my wife passes by this desk, she very pleasantly and chidingly says, "There sits my new car." And she's absolutely correct, because in the equipment that you see spread across this desk, we have about $26,000 tied up. This is not something you'll do in the back closet, folks, and if you're going to do it, it needs to be done correctly. Now, in the traditional evaluation of blood, certain parameters and measurements have been classically evaluated to determine what is normal function. The things that you may be accustomed to looking at will include serum chemistries, the blood electrolytes, endocrine moieties, pH and gases, and in some cases for the microbiology, we do classical culturing. These are all very useful, and they are a piece of the puzzle. We also notice that in traditional measurements in a CBC, we'll get a red and a white count, a crit and a globin, a differential, a red cell indice group, and a platelet count. People, may I divert just briefly to mention that some of you today work in operations that do not do CBC differentials. Insist on it. And do not use one of these Coulter counter-generated automated diffs. You want to have a manually done differential by a pathologist or a technologist trained to read blood cells. The morphology of those cells and certain aspects to observe in them have not been adequately measured by the automated counters. I recently encountered a case coming from the Mayo Clinic, and there was no differential with the CBC, and I asked the doctor, "Well, where's your diff?" "Oh, at Mayo we don't do them anymore. They don't really have that much value." And besides, most of the doctors don't know what to do with the data if you gave it to them. That is an indictment. And I want to tell you that we missed the boat with mercury and other dental irritant patients when you do not have that differential. Also, may I mention that the platelet count. Does anybody know what adequate means? That's what they put on most of your reports now. They'll simply say that the platelet count is adequate. You ought to send that back to the lab and say, please do a count. Now, healthy and normal. The following qualities of blood cells are deemed to be normal and expected in most apparently healthy donors. We have not selectively challenged or weeded, but we've simply found those people who have no peculiar symptomologies, no peculiar problems. We notice that these are best taken from the marginal pool, either at the fingertip or the earlobe. They should be examined quickly. Usually, we must have registration within 10 to 15 minutes of collection, which means the patient must be at lab and the lab must be ready to examine when they are received. Always assume, please, that when you work with blood specimens that they are contaminated infectively. Use appropriate protective techniques. I must tell you that after working in the Army labs, I have little faith in rubber gloves. But anything we can do to be cautious, to be clean, and to have a good technique is important. I watch dentists in particular who are judiciously cautious about working in the mouth, but take no precaution at all if the blood comes from the hand or the arm. People, it's all the same blood and it packs the same problems. To get the specimen that we're going to be looking at today, we use an isopropyl alcohol sponge to remove oils and fats from the skin. If I were using the fingertip today, I would vigorously scrub that for about 60 seconds. Not because the patient's finger is excessively soiled, but because I want to stimulate a marginal flow and a peripheral flow so I don't have to squeeze and mash the specimen out of the hand. The alcohol interferes with some of the qualities of the blood that we want to see. We need it to get the oils and the fats away, but then just ask your patient to wave it through the air. We preferably do not wipe it anymore. We've learned better. Just let them air dry that finger until the alcohol is completely evaporated. Puncture the site once with a sterile lancet and gently express a 2 to 3 millimeter globe of blood onto the surface, and then properly dispose of the lancet. Folks, when you lay that lancet down on the countertop and later poke it into your arm while you're working there, it's just as dangerous as the needle you use to put in the anesthetic. And yet we frequently forget that when you're working with a lancet. Collect the globe of blood onto a clean glass slide by gently touching the slide to the surface. Don't mash it down. As soon as contact is made, draw the slide away and adequate blood will come with it. And very quickly cover slide. We do provide a clean cotton sponge to the patient to cover the puncture site afterwards. And we again recommend and urge you to properly dispose of that sponge and other requirements. People seem to take great care when they're working in the mouth, but as soon as we get out of the mouth, they forget that other blood can have the same kinds of problems. We put that now onto the microscope, and in this particular kind of microscopy, you'll need to use an oil coupling to the slide, both from the condenser up to the slide and from the slide up to the objective. What are the things we're going to look for in red cells? We're going to cut to video in just a few moments and I'll show you some of these things. But in preparation for that, please notice that the relative uniform size and shape is important. We don't want to find heavy aniso or poikilocytosis, variation in size and shape in a normal patient. We don't want any evidence that there's a hemopoietic tissue stress, and that often is indicated by aniso and poikilocytosis. We want to be sure that the cells have a smooth and entire membrane. We also want to find that the total count is within normal bounds. 4 to 5 million is a range that we have come to consider normal. You'll notice that that is far narrower than what's printed on your lab sheet. Anybody ever wonder where they get normals in a laboratory? Normals generally are constituted by taking the last 10,000 sickies to come in, taking an average of their indices, taking 1 and 2 standard deviations outbound, and there you have normal range, all determined on patients who were certainly not normal. They wouldn't have come to the lab if they were. We have found that 4.5 to 5 million is a normal red count. Anything under that is suppression, anything over that is compensation, and probably accompanied with a substantial degree of non-functionality. We want to make sure these cells are free of marked cell adhesions and rouleaux. We don't want any abnormal globulins there. Sometimes the cells just tend to stick to each other. Sometimes they'll have a classical stack of coins formation. We'll show you some of that in the video material. In a healthy red cell formation, we would like not to have this present. The proper shimmer pattern and coloration. In Naison's microscopy, you'll see that the membrane of the red cell shimmers. It is that constant motion that allows part of the pumping mechanism to move gases in and out of the cell, to expose the cell surface to things in its environment. The cell does not sit there like a balloon. It is constantly in action and expending energy, and as it does so, that pumping will bring new materials in contact with the importing surfaces. We note that elasticity and compressibility are important. These red cells especially are tough bounders. You can mash them and twist them, you can stretch them out like footballs, and when you turn loose of the pressure, they sort of bounce and rebound a few times right back to their classical round size. If they do not do this, we do not have normal red cells. Any of you have labs that go to this extent, by the way, to evaluate whether or not red cells were healthy? Ghost cells are rare or unseen. These are largely cells that have lost membrane integrity. They may be populated by microbial entities. We're going to show you some of those today. And also, in many cases, ghost cells will have been toxically incapacitated. Ghost cells themselves may be carriers and collectors of toxicity, and we should remember that when they are seen in high numbers. There should be no obvious intracellular inclusions. We don't want chemicals there, and we certainly don't want any microbial entities. I'll show you what happens when they are present in our video. Now in the white cells, what is the distribution? Is it normal? We find that about 55% granulocytes, 40% lymphs, and 5% others is a normal percentage distribution. What is a normal white count? We find that a count count is between 5,000 and 6,000 cells. You'll notice that again is far narrower than most laboratory reports. Anything less than 5,000 is suppression. Anything greater than 6 or 6,500 we would consider to be compensation. If you do a phytomitogen test, if you do a lymphocyte viability, if you do other functional tests to those white cells, you will find that substantial numbers in excess of 6,000 total count will be totally non-functional. They sit there, they count, and the doctor says, there's nothing wrong with you. See, you've got 8,000 white count, you've got all kinds of white blood cells. The fact that none of them work was never addressed. We'd like to be sure that their size and shape are typical. We don't want grotesque nuclei, grotesque outer membranes, and certainly we do not want unusual appendages. I'll show you some of those today. The nuclei bear expected structure and pattern, especially in Naison's microscopy. You will miss these in stained specimens altogether because it stains nondescriptly and fairly uniform. But in Naison's microscopy there are peculiar textures and patterns, and you can watch those things move and change in a functional cell. We'd like to be sure that the cytoplasm content and volume are typical. Are the granules, the inclusions, and the substructures within expected limits? We'd also like to know in healthy white cells that their activity and motion is normal. If you have a white cell that's balled up in somewhat of a circular formation and it sits and there is no movement whatsoever, you have a cell which likely is toxically impaired. If you can't watch that thing crawl around on the stage like an amoeba, it doesn't have any capacity. And it doesn't take a rocket scientist to make that observation. May I also mention that healthy white cells have a normal coloration and autofluorescence quality. We look for those colors, and by spot spectroscopy, we can follow a pattern of peaks to determine not only that there is health and function, but we've also learned that in those patterns we can detect some of the chemistry that is actually taking place at the given moment. And it is not now impossible to get spectroscopy equipment that will narrow down to about 0.5% of the field where you can spot that right on a certain structure and say, does that structure have peroxidase activity? Is lipase activity there based on the spectral analysis? In vitro durability. If these white cells are healthy, they're going to last for a little while on the microscope slide. If they don't, there is a fragility present that you'll want to know about. Now, platelets. That one that they always mark adequate on your report. What is a healthy platelet? Thrombocytic tissue. First, there are no large distended forms, no grotesque morphologies. We have seen platelet mats that will reach across the stage for 15 or 20 microns. Folks, if you find those out in marginal blood, that is not a healthy patient, and it certainly is not a normal platelet, although that is often ignored in so-called differentials. We also want to be sure that in the size and the shape that there are no substantial collections of refractile bodies as imaged in Nissans. We want to know that the numbers are within bounds. What have we looked at and found to constitute a normal count? A normal platelet count, to our feeling, is 300 to 350,000. Anything less is suppression, interference, toxicity, and anything above is a compensatory mechanism. The cytoplasmic content does not have the refractile bodies nor the spherical underlinean bodies. I'll point these out as we go through the video. And finally, there are no microbial attachments. We have come to learn that substantial parts of cell wall and aberrant microbiology, cell wall deficient and aberrant microbiology, takes place in the platelet tissues. The following video will show some of the qualities of blood that we would like to look for. And if I could cut the projector into the first tape, please.
A little light fan here. Anyone have a flashlight?
The color that is seen in these images is due to the illuminating system provided by Nissans microscopy. The erythrocytes, or red cells, will have a brown sandy coloration, and the white blood cells will be typically colored, such as these PMNs, or polymorphonuclear neutrophils, one kind of white blood cell. It is not unusual that many of the red cells will have somewhat of a shimmer pattern, suggesting an active membrane with gaseous exchange. As we have mentioned previously, the granulation pattern, content, rate of activity, and texture are all important in judging the function. We believe that the colors which are shown here are also somewhat indicative of the chemistry that is taking place. Please note that the white particulates out in the open spaces represent the Nissans somatids.
How many microns are they in diameter?
The red cell typically is...
White blood cells will be motile, especially the PMNs. Please note that the cell just out of center field, moving towards 3 o'clock, is actively in motion. It's dragging a small pellicle behind the cell, and it seems to push its membrane out ahead of itself and then let the content of the PMN flow into it. It is not unusual that we will see the granules within these cells occasionally give off a white or even an orange color. And we believe that when this happens, there is an indication of high-energy phosphate bond expenditure, as well as some peroxidase activity in progress. As the cell moves up to the top of the frame towards the RBCs, increasingly we can see the pellicle that is being drugged behind the cell. This is an example of healthy blood cells and is indicative of the differentiation that is possible by proper illumination. In these particular images, we're especially interested in the microbiology. That is to say, the cellular and mycelial forms that appear in the open spaces between the two columns of red blood cells. We note here that there are some branching forms, and certainly the microbiology is obvious on the left side of the screen. In this particular view, we have several lymphocytes visible, together with some mycelial form of microbiology down near the 6 o'clock position. The lymphocyte that is up near center field has the small refractile bodies in its cytoplasm, which Nissans has suggested not to represent individual virus, but which may be indicative of aggregations of virus. Not unusual that these granules will have a green or yellow cast to them. Sometimes there are interesting phenomena to be seen, even in healthy patients. An example is the PMN, or polymorphonuclear neutrophil, which is now on the screen in the center of the field. Please notice the tendril or fibrils that feed out. These fibrils have been seen to be in motion, and over the next moment or so, you'll notice that they may tend to fold right down against the cell as if they are sweeping the environment and bringing material into the cell, such as we see around the 10:30 or 11 o'clock position of that cell. It is as if we are bringing material in to be phagocytized. To date, we have not been able to find any reference to this activity in any of the hematology books, and we believe that although these structures may have been seen in fixed and stained specimens, this may be among the first actual video live action that has reflected this activity. Sometimes, when there are abnormal globulins or adhesive factors on the red blood cells, we get these peculiar stacks of red cells, such as are seen here. This phenomenon is referred to as rouleau. We also notice here in various places that these red cells, even when the rouleau factor is present, also have certain elasticity qualities. Elasticity is one of the qualities of red blood cells for which we have concern and which we mentioned in the earlier slides. And here we can see a PMN pushing up through a group of red cells. Notice as this white cell pushes up through the group that they sort of bend and twist and conform to the shape of the white cell. This elasticity is a quality that we would like to see in healthy blood. Sometimes red cells will lose their integrity completely. The membrane will have holes punched in it for various reasons. It will lose its cytoplasm, and we end up with ghost cells, such as those light structures seen just above the main mass of rouleau erythrocytes here at this view. Another phenomena of healthy white blood cells that we like to watch for will be seen here. You'll notice near the center of the field that there are two PMNs adjacent to each other. The one on the top will begin a motion whereby it flows, and you can see it beginning to push its pellicle out towards the 9 o'clock position. As we watch this sequence, that upper cell will begin to flow its cytoplasm and granules and push out towards the 9 o'clock position of this image. This motility function of PMNs allows them to be chemotactically attracted as well as electrotactically attracted, and gives them the capacity to move into the region where they are needed for inflammatory response, for phagocytosis, and other phenomena. You may notice here also, as these granules move along, that the nucleus is being brought along as well. Rather than being bunched up back at the end, it has actually brought the nucleus along at the forefront of where it is pushing the membrane forward. While we do have some activity in the PMN that is left behind near center stage, we also notice that it is not migrating anywhere. Of interest also to those who are interested in the microbiology, there is a mat immediately below the motile PMN, and that mat is one of the devices that Enderlein describes as a long-term survival form for various microbial entities. And while these white cells move around, we continue to note the elasticity of the red cells. Note how they compress as they try to move around this white cell. They can compress in one direction and then swing back and compress in another. We notice excellent elasticity as they're stretched out and then spring back to their normal shape as soon as released from whatever has constricted them. These cells are really quite tough. Not only are they resilient and elastic, but you'll notice here a small yeast or levure form dependent to the one red cell, which is now sliding down towards the 730 position. Although not a true yeast, this is a bacterial form in the pleomorphic cycle, which is yeast-like, and which is described by Naissans as one of his cycle stages. Having seen some normal or relatively normal blood specimens, we would now like to turn our attention to what happens to the blood cells when adverse materials are added into the mix. We're going to be going through a sequence now which will show the effect of mercury added at 1 part per 10 million mixed in LOX solution. We'd like to show in sequence the changes that can happen to cells, demonstrating that these cells can in fact be used as a marker and indicator of toxicity and toxic effect.
Can we cut right there, Ed?
To this specimen, we have added mercury.
May I have the slides again, please? A number of you may remember that we committed that we would have a videotape available by last December. As our work has continued, we've continued to find new things that really ought to go into the video. Some of you think we're never going to produce that. And in fact, what we have done is to take a number of clips from that video production that I'm using here today. We need to go to the second tape next, Ed. What happens when mercury is added? Many materials are bioreactive and had adverse effects on the blood cells. However, none are any more severe nor dramatic than mercury can be. The changes that are often seen, we notice that in donors who have sensitivity based on the Clifford materials reactivity testing, that these effects are much more pronounced. There is likely an IgG-IgM mediated component to the problem, and we suspect that systemic sensitivity is certainly a factor. The reactivity testing we do, and this is a picture of our testing bench, and that reactivity, of course, we have addressed this on other occasions with the Academy, is based on detection of systemic immunoglobulins by precipitin reaction. The blood must be freshly collected, either as whole or as heparinized blood, and we prefer the marginal pool for greatest reactivity potential. We also note that mercuric chloride for the challenge is mixed and diluted to 1 part per 5 million in LOX solution. Now we're going to add this, and I have here a recipe for LOX solution. Some of you will ask, why didn't you just use physiologic saline like everyone else does? You'll notice that our sodium chloride content and other mixes at the top are somewhat reminiscent of physiosaline, but we are particularly concerned with the buffering and other cations because of the microbiology. And LOX solution was originally intended as a component to a microbial medium. and it is very protective to cells at the same time. Equal amounts of fresh blood and locked solution are going to be mixed for a final mercury concentration of 1 part per 10 million mercury. We have done this to provide an environment where we are fully 1 order of magnitude more dilute than most of the regulatory agencies claim to be safe. They say that 1 part per million is perfectly acceptable and will hurt no one. We therefore have taken our studies to a level of 1 part per 10 million. The following video will demonstrate the effects of mercury on whole blood. We are using freshly collected blood from various donors and at 1 part per 10 million. If we could cut the slides and go to video number 2, Ed.
When mercury has been added to the cells and they have incubated for about 30 minutes, it is not unusual to
Ed,
see
could we
both
cut that?
accelerated and unusual changes taking place in the microbiology.
Can we cut it?
Note here that there is a rod floating down from the 12 o'clock position.
Ed, if we could, let me go back to the first tape where we cut it a moment ago. Thank you. May I just mention, as this is coming up,
30 to 60 seconds, we begin to see erythrocytes which are undergoing change. We also note that the PMN in this view has taken on an intense white color as high-energy phosphate bond expenditure becomes intense. We note that these changes do not take a great length of time. Within 2 to 4 minutes after exposure to mercury, we note that more and more of the red cells are being affected. The rouleau factor is breaking up. We note some changes in the apparent intensity of activity inside of these PMNs. And we note that the membranes on many of the red cells are being compromised. In 5 to 6 minutes, the changes have become intense. Notice that the membranes have begun to shrink. There is substantial aneso and poikilocytosis, or change in size and shape. We find that lipid is beginning to ball up in strips on the membranes of many of these cells. We also note substantial changes in the coloration of these cells. Notice that the activity rate of the somatids out on the open spaces has changed dramatically. When mercury is added to these cells, respiration apparently changes as well based on the appearance of the shimmer pattern. Now, remembering the image of these cells, this is after only 5, 6, or 7 minutes. Now, we're going to go back and comparatively look at this blood within the first 30 to 60 seconds. It doesn't take much of a genius to see the changes that have occurred in the blood cells with mercury exposure.
could we go to the slides, please? May I please caution you and offer the caveats that these tests are done in vitro. Homeostatic factors that might be present in the body do not have much of any play out on the microscope slide. We also notice that various protective factors that may be present from submoieties and plasma are largely compromised once we've had exposure to the air. And so before anyone jumps and screams, let me mention that no, people who have amalgams don't have these kinds of blood problems in total. But it is not unusual to find some patients that will present with aniso and poikilocytosis. You know, that's one of those qualities that they don't mark on the CBC anymore. We have some of these patients that will have shifts in the population of white cells. We have patients that will present with abnormalities, and we say, well, yeah, I saw a couple of broken up red cells and I saw a couple of strange ones, but we don't worry about those. The reason we need to worry about those is that that is indicative of long-term compromise of these various homeostatic mechanisms. Now, mercury is not alone in its ability to induce or precipitate various kinds of systemic problems. Other metals can certainly have a similar kind of effect, and we'd like to show you some of those today. We notice that various organics can certainly bind and carry these metals, as well as providing toxic actions of their own. We note that sometimes there is an inability to detoxify. Toxic products are going to be held in the patient. And when this is the case, it is not unusual that we will have substantial long-term problems clinically. It has always been of interest to me that one of the places mercury will bind quickly is in adipose tissue, the stuff we all carry around right here, at least I do. When we have the stress of the overnight fast, some of the adipose reserve is going to be mobilized. When it is mobilized, anything that has been stored in that fatty tissue is going to be released. This is why patients feel so cruddy when they get up in the morning. Not just mercury and aluminum and nickel and other things that have deposited in adipose tissue, any of the toxics that are there. People feel achy in their joints, they don't feel like moving around until they get up, shower, and have a little something to eat and drink, get a little caffeine in them in some cases, and then the day is bearable. By afternoon, we feel just fine because we've been eating through the day. We are now redepositing, and guess where all of those toxics that did the dirt this morning went? They redeposited in adipose tissue so you can have them do their dirt again tomorrow morning. Now, the following video will demonstrate the effects of a variety of different moieties that we have looked at on blood cells. And Ed, I think this is number 3.
One of the truly fascinating applications of Nissan's microscopy is the ability to observe the effect of toxic materials when challenged against live blood cells. Here are some relatively normal red blood cells from an apparently healthy donor. We have inserted a timer so that you can tell in real time the typical motion and speed with which things happen. In the images which follow, we're going to take some blood from a pool of healthy donors, and one by one we're going to introduce some challenges to show you what happens when toxic materials are introduced into the presence of live blood cells. We're going to use concentrations of 1/10 part per million or 1 part per 10 million. Remembering that various regulatory and government agencies say that 1 part per million exposure level of toxic metals and other materials is completely safe. These red blood cells came from the same apparently healthy donor that you just saw a moment ago, except that they have been challenged now for about 60 seconds with aluminum at 1 part per 10 million dissolved in LOX solution. We notice immediately that there is a dramatic change in the color and in the shimmer rate of the membranes. There is marked aniso and poikilocytosis present. It would appear that in many of these cells, the lipids lining the membrane have begun to ball up, and it is obvious that many of these cells are probably damaged beyond any recoverable point. These cells have been exposed in a similar manner, except that beryllium was the challenge rather than aluminum. Notice notice the shift in color in the white blood cell, the PMN that is present, and the complete loss of the shimmer pattern in the red blood cells. And we also notice that there is a dramatic change in the number of apparent somatids that are out in the black spaces. Beryllium is known to be extremely toxic, and it would appear here with a little anisal and poikilocytosis that membrane function has been substantially altered by its presence. When a fresh blood specimen is exposed to cadmium, we find again that there are marked changes. The shimmer pattern is not entirely lost here, and we notice that there is also some normal modicum of coloring in some of the cells. However, it is apparent that some of the membranes have begun to be compromised. A few of the cells even show some evidence that lipid strings are now beginning to show on the outside of the membrane structure themselves. When cells are challenged with copper, a number of interesting aspects take place, but none more unusual than can be seen in the small PMN, the bright-colored cell down in the lower left-hand corner of the screen. You'll notice that the coloring has changed from normal cells shown earlier. The activity rate is dramatically increased. In the Nissan's illumination system, when we see the loss of the blue-violet color and the increase in white and yellow and orange color, this is suggestive to us of high peroxidase activity in the cell. We also associate this condition with the general loss of lysozymal activity in the cell. Red blood cells that are exposed to copper also show marked anisal and poikilocytosis, degeneration of the membrane, and we notice that the shimmer quality is lost along with much of their color. Copper is not the only irritant that greatly enhances the metabolic rate of PMNs. Here fluoride has been applied, and by spot spectral analysis, we know that there is an extremely high expenditure of phosphate bonding. Red blood cells that are exposed to fluoride show a very peculiar clumping action, not the normal rouleau or other factors we expect with heparin, but here you will see that there is a very strange aggregation, and only after substantial mechanical teasing can we actually begin to see individual cells. Fluoride-exposed red blood cells also tend to round up. Instead of being donut-shaped in the traditional erythrocyte fashion, you'll notice that many of these cells are now almost spherical or have only slight dimples. There is also the formation of some substantial crystalline material, which is as yet unidentified. After prolonged exposure of perhaps 12 to 15 minutes, we begin to see some of the same changes that we have seen with metals. These cells are still functional, but it is very apparent from their coloration and from their activity that they no longer have the same function as the healthy donor did at the beginning of these images. If left alone for perhaps half an hour, these cells which were mechanically teased apart tend to regroup and reclump. Their thickness becomes so intense that the hemoglobin actually starts to give coloration all from its own. It has been said by many that one of the safest materials to use for many patients is gold. It doesn't take a scholar looking at these images to see that gold is perhaps the least altering of materials that we have challenged blood with. The elasticity of the red cells, as seen in the center here, remains very good. The somatid level and count remains good. The activity in the white blood cell remains very stable and expected. The shimmer patterns and the coloration are quite normal and acceptable. It would appear that where there is no sensitization to gold, gold may in fact be truly the noble metal of dentistry. Iron is an element that is obviously needed for good health, certainly for the maintenance of hemoglobin and other structures in the blood. But when exposed in the chloride or sulfate or oxide or nitrate forms, iron can have a very deleterious effect on the red blood cells. Here we notice thickening of the membranes, we notice deformation of some cells, and we notice that there is in fact corruption of the content of a number of the red blood cells. Patients can have a sensitivity to iron. Many have discussed and described the toxicity of lead, and in neurologic tissue it is a special problem. But we can see here in the metabolism and oxidation rates that are taking place in these red blood cells, as well as cell deformation, that lead does have a direct impingement on virtually any cell membrane. We notice here that many of these cells have begun to deform and decolor, and it is quite obvious that many of the somatids out in the black space have also been lost. The toxicity of lead, therefore, may reach into a number of different body systems. Nickel also has a marked effect on blood cells, although the effect is somewhat slower to develop. You'll notice here that approximately 30 to 45 seconds into exposure and mixture, that the cells have begun to show changes but have not entirely lost all of their functional indications. However, if we let these cells incubate for approximately 30 to 40 minutes, a very marked change takes place. You will notice here that the color has shifted dramatically. The high energy expenditure of phosphate bonding in the PMN is intense, and the cell is in the throes of death. You'll notice that the somatids have become very broadly distributed, and the cells themselves are rapidly undergoing decomposition. One of the areas that is always of extreme interest is that of mercury, and there is good reason to have concern. These cells show the very marked and defined changes that even 1 part per 10 million mercury in LOX solution can have on red blood cells. The changes in the thickness of the membrane, the changes in metabolism rate, shifts in color, aniso and poikilocytosis, the very dramatic drop in the number of somatids in the black spaces is of extreme interest. We find that mercury, in fact, is one of the most directly toxic of all the materials. Some have suggested that silver is obviously as innocuous as gold is. It does not take a scholar looking at these images, however, to see that silver introduces some problems all its own. There is obvious crenation of the red blood cells or dehydration. We also see that there is some peculiar effect taking place on the microbiology involved with certain of these cells. When considering the silver-mercury amalgam, it is possible that in many patients, perhaps in as many as 9, 10, or 11% of the population, that silver itself can be as deleterious as mercury is. One other element in the silver-mercury amalgam, which is highly suspect, is tin. Notice in these images that many of the red blood cells exposed to tin have begun to round up. They have lost the donut shape and have again just small dimples showing in the cell surface, while the color has shifted now away from the more traditional brownish orange color to a more blue-violet. We notice that there are some changes in the somatid levels, and we do see some destruction and degradation beginning to occur in cell membranes. Tin may be an insidious problem where it is used to help with the bonding of certain porcelains to metal.
May we have the slides again, please? I would like now to move to the final phase of our presentation today. Ed, if I could have video number 2. Can some effects be reversed? Is it possible to prevent some of these damages from taking place. I would like to actually break here into two segments, if I may. In the first, I would like to draw back to show you a short clip video that stresses the microbiology that is present when mercury is used. We've gotten some video clips shifted. Our post-production studio, I think, gave me the wrong tape, and I then labeled it and came flying out the door, and I guess that's what you get for preparing at the last minute. But I'd like to show you just a little bit of the microbiology effects from mercury, and then I'd like to go to some work we are doing which may suggest the possibility of prevention or reversal. Could we cut the slide, please?
Have developed appendages and are rapidly developing towards mycelial forms of bacteria. These changes are exacerbated by mercury and can be forced to occur in even the most healthy of individuals. In this individual red blood cell, we notice the formation of intracellular bacterial forms. I call your attention first to the two larger circular bodies inside the red cell, which correspond to the yeast or levurate forms described by Naissance. There are also 4 other circular bodies. Over the period of the next minute or so, we're going to watch the progress of these bodies, keeping in mind that these bodies will seemingly connect and form a mycelial mat. This is a function that is exacerbated by mercury. It can also be induced by beryllium and tin. It is often found in cancer patients. We have also seen this in certain arthritic patients. Normally it takes several hours for this to happen, but when mercury has been added to the specimen, we can accelerate the development of the microbiology so that these phenomena can be seen in perhaps as little as 20 to 30 minutes. Note how the structure is enclosing the 4 smaller bodies, and there is some additional development in the upper yeast or levurate form near the top of the yeast form. It is not unusual that we will see this in many of the RBCs that have not become herniated or in which the cell membrane has been damaged. And we see here that the distension continues to form. Here is a view of cells from an apparently healthy donor, where we see the interior microbial content developing in less than 1 hour in virtually every red cell that is shown. This lymphocyte shows a very peculiar lack of texture. It shows that the differentiation of the nucleus has diminished substantially. We also notice splitting of the refractile bodies that Naissance characterizes as the viral aggregation. It is apparent that both structure and function have been severely altered in this particular lymphocyte. One facet that is often observed in bloods that have been exposed to mercury, tin, beryllium, aluminum, cadmium, and perhaps several others is the accelerated formation of the Naissance thallus stage. These are long fibrous casings which give rise to literally millions of new somatids. This is the end of the Naissance macrocycle. This structure, which is now being seen, is one such thallus. You'll notice that not only do we have many red cells which have the intracellular parasitism by bacterial forms, but the thallus itself has become huge, differentiated, and this one has apparently lost most of its content. The thallus, which is long and fibrous, will often have a bulbular head at one end. Here the rounded head is seen together with spillage of the content that has been in it. We note that in this particular structure there is substantial activity, and the somatids have been scattered already as breakage has occurred. Remembering that metals can exacerbate this, normally the development of the thallus is seen only in the late stages of cancer, AIDS, and other extremely severe and debilitating diseases. even in patients where cells are not extremely severely affected by mercury and other heavy metals, the microbiology still can be. Notice just out from center field towards the 1030 position, up near the 130 position, and from RBCs suspended just below the 12 o'clock position, a number of bacterial forms are seen here. Pressing the very limits of the microscopy technique, here these red cells, which have shrunk somewhat, show extensive interior development with microbial growth. This again is exacerbated and accelerated by mercury and other heavy metals. Is the thought not suggested that those patients who may not have extreme mercury symptoms but still have debilitated immune systems and still have the inability to fight off disease may have the effects of mercury because of the microbiology that has been induced? These cells have been challenged with mercury less than 1 hour. Look at the extent to which the microbial growth has formed. And finally, this particular form is referred to as a medusae or a medusal head. This is a microbial form which has mycelial and fungal-like qualities. It is frequently seen in AIDS patients. Occasionally, it may be found in cancer patients. This particular medusal form was induced by mercury exposure for about 1 hour in a patient which has no diagnosed disease process and appears to be completely healthy. Mercury may reach into a number of disease processes that are far removed from anything that is yet recognized, even by the Academy and other scientific bodies. We recognize that the microbiology must be dealt with. And I would also add that these are forms that are not classically recognized by hospital-based microbiologists. If the medusae form can be metal-induced, then can metals be attributed to a contributing factor in degenerative disease?
May I please have the slides again? Can the microbiology, can the toxicity possibly be reversed? To effect a change, first of all, we need to stop the input of the toxic substance. If it is coming from the teeth, we may want to consider a replacement of materials. If it's coming from outside the body, we may have an obligation to counsel the patient on how to alter their exposure to these things from food, water, or environment. If we remove it, there needs to be a positive action taken to get these toxics to release from the tissues where they have become bound. We note, and I did earlier throw in the information on lead. Within the last couple of months, we have added to the repertoire of materials we test for in materials reactivity testing. And one of those is arsenic. Why do we worry about lead and arsenic? Hopefully you don't use the glazes from some of the East European or mid-Asian sources where they still throw things like uranium and lead into the glazes. Supposedly then, arsenic and lead are not used in dentistry. We include them because they are part of a body that react at the same binding sites on tissues that mercury and aluminum and nickel will react with. It is not unusual that we see people saying, well, I have this level of mercury and this level of lead and this level of arsenic. Folks, it has been very adequately demonstrated in the literature that these are additive heavy metals. We take the lead, and then the arsenic goes on top, and then the aluminum, and then the cadmium, and somewhere up here it takes a couple of nanograms of mercury to push a patient through a threshold. We do not take these body burden levels as individual measurements. We add them because biologically they are additive, and we have to mobilize them. You cannot expect that they're just going to fall off the tissues and go away. So we take action to get them off. We also want to enhance voiding capacity. I greatly appreciated Dr. Vimi's presentation this morning on kidney impairment. Certainly with challenges that can take place, such as creatinine clearance or inulin challenges, we can show that when these metals and other toxics are removed, function levels for elimination come up. We want to be sure that the bowel and the lymphatic and sweat functions are also adequately supported. These are all excretory measures, and we support any of those actions within the patient. We also counsel on the lifestyle changes. You can take the mercury out of someone's teeth, but if they got up this morning and used a wetting solution on their contact lens that's preserved with mercury, and then, as some of the ladies have in fact reported doing, they take a preparation H suppository and rub it on their face because it tightens the skin and makes it tight and youthful in its appearance. And then they go to lunch with their bridge group, and these ladies have shrimp and clam and oyster, all you can eat. And then these same people stuff a suppository up their rear end, a preparation H for their hemorrhoids, and then they go to dinner tonight and have a lobster thermidor. And to top it off, when they get home, everybody's still a little hungry, so they have a fresh tuna salad. I promise you that you can take the stuff out of the teeth, and it's not going to make a stitch of difference in how patients feel. Some of you have been challenged by patients who say, "You took this stuff out and I don't feel any different. What good did it do?" Well, if we can get the tuna out of your diet and all of the shellfish and most of the warm water fish, if we can quit eating those trout from the Rocky Mountain streams, if we can stop eating Minnesota fish, if we can get the preparation H out of your life, if you quit taking those allergy shots that are preserved with mercury, and if you quit doing all of these other things, it will make a difference. Some of you stood blandly by and said, "Well, gee, I don't know what's wrong." People do not overlook the obligation. And if the professional does not have time to do this counseling, for certain, have a hygienist or someone on your staff that will tend to it. Finally, supportive care through vitamins and supplements. There is some evidence that certain pre- and post-treatment supplementations can be effective, and this is where I want to move now with the discussion. We have some emerging evidence that may make this particular consideration of interest. The following ideas and protocols are experimental and should be judged in that context. I am not here to promote someone's protocol. I also want you to know that they're based upon the thinking and derivatives that come from Drs. Page, Price, Pottinger, Pinto, and others. These are not original to Clifford, please. I don't have the smarts to do that. Information and studies which follow have not been correlated to any disease condition. Murray Vimy, I take my hat off to you if you're still in the audience. We do not have to hook mercury to a disease. And you stole my line, Murray. I want you to know that to demonstrate toxic and deleterious effects, a patient does not have to have multiple sclerosis. They don't have to have AIDS or cancer. They don't have to have rheumatoid problems. They can just feel lousy. We do not need a disease correlation, and these studies do not in any way attempt that. They do not necessarily imply statistical reliability of the findings. This is work that we have in progress. I have seen enough evidence to date that I feel comfortable in telling you about it. But please, this is not ready for absolute publication to be relied upon with a certain error percentage. They are preliminary. And finally, I am giving these thoughts to stimulate conceptual thinking and not to promote the philosophy of Dr. So-and-so or Mr. So-and-so or anyone else. Please, these are for your benefit to stimulate thought. What are the protocols? First of all, healthy donors with no known disease diagnoses or other problems were baselined after 7 days without taking any kind of exogenous supplementation. We did not in any way restrict their diet. We told them they didn't have to change their lifestyle. All we wanted them to do was to stop direct supplementation with vitamins, minerals, and certain other products. After baselining them, these test subjects consumed test supplements for 4 days. We went 96 hours prior to their next blood test challenge. Again, no dietary restraints were applied. Finally, they stopped supplements for 7 days prior to reconfirmation of baseline. Again, no restraints to diet. We then repeated supplements for 96 hours and looked for changes with challenge. And then finally wound up by taking them back to no supplements for 7 days to clear residual effect and to reconfirm baseline observations. Is that completely scientifically sound? We believe it is reasonable, but again, this is one of the reasons that I have said these findings do not imply statistical reliability yet. We are still looking at clearance periods. We are still looking at supplementation periods. Protocol number 1 used vitamin A, 20,000 international units a day. It is formed, it is not beta-carotene. It is from vegetable source. One of the worst things you can do is to take it out of cod liver oil. It is water solubilized. We used vitamin C as a straight ascorbic acid in time-release form, 2,000 milligrams per day. This can be divided and taken twice a day, or it can be taken all at once. We used formed vegetable source vitamin E, 400 international units per day, and 500 milligrams of common L-lysine. Protocol number 2 used only certain digestive aids. In this protocol, we used as a first consideration amylase and/or lipase. We wanted something that would work on lipids and fats. Secondly, we use bromelain and/or papain, and I put the and/or here because we have looked at several products. If one of those two is present, they seem to have equal benefit. Please, I am not touting any brand, and I don't sell these things. We wanted something to work on proteins, so we used protease and/or trypsin and/or pepsin. In all considerations, we made sure that there is some betaine hydrochloride, and finally, we wanted to have some chlorophyll present, usually as a dehydrated barley green, a wheatgrass, or in some cases an alfalfa supplement. Seems to work just fine. At all costs, we have learned to avoid spirulina, chlorella, and other algal sources. I cannot tell you all of the reasons, but they do not have the effect. Protocol number 3 used only chelated minerals. These are chelated as glycinates or other such forms, and this will give you an idea of what was present generally in the formularies that we used per 24-hour period. You'll notice that these are certainly not excessive. And finally, a fourth protocol takes all 3 of these protocols and puts them together. 1 morning dose of the vitamins and minerals was used in most cases here. The digestive aids are consumed 3 times daily at meal. The following video is intended to demonstrate typical results using blood cells as indicators of effect. Now, as you watch the material which follows, is it possible that if material is administered preoperatory for perhaps 3 to 4 days, and then a supportive care regimen follows postoperatory for a period of weeks, will it make a difference? Could we cut the slides and go to video 4, please, Ed?
You will recall this image from previous presentation when we spoke about the effects of mercury and those things that happen to cells after 5, 6, 7 minutes of time. What happens when we do something to protect or reverse this condition for patients? These blood cells came from an apparently healthy donor, the same one whom we've been using in previous tests. We do note here that many of the red cells are not nearly as degenerated, and these cells have now been under the exposure to mercury for about 10 to 12 minutes. What is the difference? To these cells, we have applied vitamins A, C, E, and a little bit of lysine, as mentioned in our previous discussion. The cells are not totally protected, but we notice that this donor, having been under the influence of these 3 vitamins and 1 amino acid, does not have near the extent of destruction that have been seen in some of the previous red cells. This particular segment of cells represents those that have come from a donor where we are using only chelated minerals, including zinc, manganese, magnesium, germanium, selenium, and a small bit of potassium. We note here that the cells are not nearly as severe in many cases as those that have been previously seen, and the white blood cell, which is now on screen, is not nearly as defunct as some of those seen in previous mercury exposures. These cells are representative of a donor which has used digestive enzymes as we have described. Here we have several classifications. We notice that the digestive enzymes have apparently given a little bit of a protective effect to the cells, and yet we do note that there is some progressive microbiology that has not been entirely addressed by this particular treatment. The cells in this segment also show considerable development of microbiology. These cells are under the influence of vitamins A and C only. We again note that there is some cellular protection, although this particular combination has not entirely and completely resolved the problem of the mercury challenge and the microbiology which it can contribute. And now finally, what happens if we combine all of the suggested treatments? Here we have blood cells that come from a donor where we have the benefit of vitamins A, C, E, lysine. We have the benefit of the chelated minerals, and we have the benefit of the digestive enzymes. We notice that these cells are not perfect. There is some evidence of stressing. We notice that some of the functionality and coloration is not exactly as we would like to have it. But these cells are certainly a far cry from others we have seen in this presentation, where mercury has had such a deleterious effect. And we notice that many of these white cells still have their proper color and seem to be functional. We notice overall that these cells are in a much more healthy position. It is suggestive that perhaps the utilization of these approaches to patient management and treatment could offer some benefit to the patient. If you are a professional working in a dental operatory, would you like your blood to look like that on the left or that on the right? If you were encouraging your office personnel to maintain health by taking protective measures, would you want your office personnel to have blood looking like that on the left or that on the right? Is it important to take protective measures? This split screen should provide some ample answers. To the professional who feels that it's just not important to worry about it, I'd like to leave this image with you. At the top of the image is a lymphocyte. It is infected and shows various signs of toxicity. The bluish cell to the bottom is a PMN. You might notice that there is a circular clear globe around the lymphocyte. Quite literally, the PMN has moved up against the toxic and infected lymphocyte, has invaginated it built a wall around it and literally is beginning to eat and dissolve that cell. If you believe that toxicity and infectivity are not serious problems in the operatory, remember that this may be the beginning of certain autoimmune processes where one of our white blood cells begins the attack on another. Is it possible that this can happen in vivo? Yes, it can, because this image was taken freshly from a donor that had a mercury sensitivity demonstrated, and within 10 minutes of challenge, we found this feature beginning to appear. We've tracked it at this point in the image for about 25 minutes. That's about the length of time it took the PMN to encircle and invaginate the lymphocyte. Yes, it does happen, and this has implications both for patients as well as operatory personnel.
May I have the slides again, please? In summary, supplements may be useful in patient management. They are not guaranteed. Our results are still preliminary. But from the thinking of people like Melvin Page, from the thinking of people like Dr. Weston Price, from the extensive clinical experience of Dr. Olimpio Pinto, we believe that there is a valid reason to look at these avenues where patients begin a supplemental and treatment regime before they ever come to the chair, and where a care program is arranged following the time that they are there. And I would also like to suggest that office personnel may derive some protective assistance from supplements. If you are concerned about the health of your operatory personnel, is there a prophylactic program that could be useful? May I leave that thought in your mind? If any of you should wish to know more about what we're doing, this is how you may reach us. Our work at this point is privately conducted and privately funded, so we are beholden to no one for the results that are coming. I would just like to tell you that as we have moved into this area of using blood cells to learn something about what's happening with toxics in the body, that we have been astounded at what is coming forth. We are, in fact, completing a video series, and the first video in that will be released in time for the AABD meeting later this month. We will show many of these same changes in case you want to take them back and show them firsthand to some of your office staff. We've had to draw the line because every time we get the feeling that we're about there, we stumble into something new that shocks us. And we finally said, this is where the video is going to end. Anything else is going into a second one. I believe that these blood cells can be used for monitoring. There is evidence microscopically to support the data that is being published. We believe also at this point that the microbiology is as important as any of the chemistry. And we believe there is strong evidence to suggest that not only do we induce microbial antibiotic resistance, but also that we can induce peculiar physiologies, and the byproducts and waste products can be very deleterious to patient tissue sites. It's a pleasure to be part of the Academy, and we wish to express appreciation for our invitation to present today.
Illinois, which is